This is probably the first truly difficult and somewhat scary new material we meet at A-level, but panic not, we've got it covered. A time-of-flight mass spectrometer enables us to determine the mass and the relative abundance of different isotopes of an element, and we can use this information to calculate a relative atomic mass. For example, if I were to put a sample of xenon into a mass spectrometer, it would tell me that I have 4 different isotopes. It would give me the mass of each isotope and the abundance. And I can calculate the relative atomic mass of xenon to be 131.31. The time-of-flight mass spectrometer is a simple piece of apparatus. Essentially, a sample of an element is injected into the spectrometer, and the atoms are ionized, forming positively charged cations. These cations are accelerated to the same kinetic energy and then released into the flight tube or drift region. We can measure the time taken for the ions to drift through this vacuum. The vacuum simply prevents ions colliding with air molecules. Lighter ions travel faster than heavier ions. The velocity of these ions is proportional to the square root of the mass. The ions hit the detector sequentially, and each ion picks up an electron, causing a current to flow. And since the size of the current is proportional to the number of ions, we can determine their abundance. So here come the equations. Once a sample's been ionized, these ions are accelerated so they have the same kinetic energy, and the unit for kinetic energy is joules. We know that kinetic energy is equal to half the mass of the ion in kilograms, multiplied by the square of the velocity, and velocity is in meters per second. Now, exam questions rarely ask you to find the kinetic energy of an ion, but they often ask you to find the velocity. So let's rearrange this equation. Velocity squared is equal to the kinetic energy divided by half m. Or we could say it's equal to twice the kinetic energy divided by the mass, which means that the velocity is equal to the square root of twice the kinetic energy divided by the mass. The most common type of exam questions asks you to find the time taken for an ion to travel the length of the flight tube. Well, time equals distance divided by velocity. Time is in seconds, we know that velocity is in meters per second, and we need the distance of the length of the flight tube to be in meters. Now we need to combine our two equations. Time equals distance divided by velocity. Or, if I separate out the velocity component, we could say that time equals distance multiplied by 1 over velocity. Now, we know that the velocity is actually equal to the square root of twice the kinetic energy divided by the mass of the ion. So the time it takes for an ion to travel the length of the tube depends on the distance of the tube multiplied by 1 over the square root of twice the kinetic energy divided by the mass, which simplifies nicely to time equals distance times the square root of the mass divided by twice the kinetic energy. Now, if you're mathematically minded and you can show how these equations are derived, brilliant. You need to be able to do this in some exam questions. However, if like me you're mathematically challenged, then it's worth spending some time getting your head around the equations and then memorise them. It's just so much easier in the long run. I'll show you how to tackle each of these calculations in the next couple of videos, so tune in tomorrow. And as always, you can find notes and practice questions and answers at crunchchemistry.co.uk. Just search for Maths Spec.